We're back for our final iteration on the home automation project.
Or at least the final for now.
Final for now, yeah. We do have some ideas on how to expand this project in the future, but we want to work on those as standalone features for integrations at a later date.
Today we're going to round everything off for this project, at least for now. We're going to cover integrating the CO2 sensor, which was surprisingly gnarly, integrating actuators based on received data, which might mean multi-threading on the server, visualizing some of the data, and where we want to take this project next. To start with, we're going to look at the sensor board as it currently stands. So for the CO2 sensor for this project, we're using the MQ135. And as we mentioned last time, this actually picks up smoke, ammonia, and CO2. But because we shouldn't be dealing with any smoke or ammonia, we are hoping we can use it just as a CO2 sensor. Unfortunately, it's pretty poorly documented, and so it took us a bit of time to suss out how to actually integrate it. The current version of our sensor board looks like this. It's pretty messy. The MQ135 works with a 5-volt heating element inside this silver dome, and as far as we can find, it doesn't work brilliantly with a supply less than 5 volts. Though this is a point of contention and it may work fine at lower powers, we just couldn't really tell, and there isn't really a good point of truth. So we had a separate power supply set to 5 volts purely for the MQ135. That's what this little power input is here. So we power the MQ135 separately. That starts to heat up with a 5-volt power supply, and its output is then between 0 and 5 volts. However, the highest voltage read that the ESP can do is 3.3 volts, which is why we have this small 2-to-1 voltage regulator here, and then we're reading from halfway through that regulator. We then have a separate USB cord connecting to the ESP to run all of the onboard systems, and that will then send data over Wi-Fi back to the server, and that will be the DHT temperature and humidity along with the CO2 level or the gas level from the MQ135. So with data coming in from around the house, we can start to sort out our actuation board with our relays. For the example of this, we're going to use this fan, which we're referring to as the danger fan. This then has had the mains power cable opened and disconnected so that it can be put in with a relay. This relay will be running this mains fan at 240 volts, and that's what this relay can switch up to. So on this breakout board, the relay is signaled by a 5-volt DC input but switching a 240 volt AC output, and this signal will be supplied from the ESP board on the sort of output actuator board, and that can pull the instructions down from the server. To clarify on this, we were running the ESP with the outputs at 3.3 volts, but this is a 5-volt relay, so we had the ESP controlling a transistor controlling a separate 5-volt power supply to control this relay. With an Arduino, you could control this directly, or with a 3.3 volt relay, you could control this directly. It's just that we don't have all of the parts that we would need to do that at the moment, hence why we did it like this. Back to the video. This is probably more complicated than it has to be, but that's because we haven't spent much money on parts and we're just using what we have available to us. We already have the relays and they're 5 volts, and you can get 3-volt relays to make it a bit sort of simpler, but I'm basically going to wire all of this up over here somewhere, and then Ethan's going to start talking through some of the code and some of the data that we've been collecting, and you should see that appear on this side of the screen.
So the next step is to pull down the data from the server. So if I just run the same script from last time, you can see that on the right here we're collecting all of the data from the specified file that we have on the server and where we want to save it to. If you want to run down off this code, I will link the previous video on screen now. And as we can see, it's sending 452 different data points, and it's all been saved in here. Now there's going to be a lot of cleaning of this data, because one of the problems with the MQ135, it takes roughly 24 hours before it's all heated up, meaning the first 24 hours of data isn't particularly helpful. In the previous video we created a plot data.py script which not only plots the data, but it also writes it into a format that we can write on Excel. I'm quickly going to edit it now. Now the script is edited, what we can do is run the script. We can see that it's not really the best to visualize it. It's difficult to see. So we need to open this into Excel and edit it. Now I have pulled the data from the text file into Excel. I've just inserted 3 graphs, one for temperature, one for humidity, and the next one for gas. Just going to talk through some of the graphs, kind of explain what's going on. So unfortunately with temperature, it's kind of just stable. One of the problems with the DHT11, we can only get integer values instead of floats or doubles, meaning it's only whole numbers, which doesn't really show much. However, if we go down to the humidity, you can see where there's peaks and troughs, and these peaks are roughly at nighttime when people are sleeping, and the troughs are in the daytime, which is expected. And now showing the CO2 graph still shows the same trend of it going up in the night and going down in the day. It's important to note that along here I haven't included the date or the day, but roughly every 100 values is 1 day. You can see in the nighttime when the windows are shut, the CO2 levels go high and when people are exhaling. However, when the room is empty and it's daytime, the CO2 levels decrease. And these peaks and troughs are really important for us. The next step in this project is to be actuating a fan based off of this data. We can see that the baseline when the value is below 200. In terms of how much carbon dioxide is in the air, we don't know the exact value, but from what we can see, when the room is vacant and the air is fresh, the value is below 200. Whereas when we've been in the room for a while, the values reach a max of about 350 to 400. If we want to actuate a fan, we want to do it at about 200 to try to lower these peaks.
So the workflow is as follows. When the CO2 value gets over 200, the fan behind us will turn on, this little dangerous number here. You can see the data coming through in the top corner of the screen, and that is the data from the sensor. It's just that we've sped it up for the purposes of this video. So at some point throughout the rest of this video, that data will proc and the fan behind us will turn on.
Whilst we are waiting for that, let's talk about some of the data. You can clearly see from the graphs of humidity and CO2 the night times where the room had been occupied and values increased. You can also see that with this data, you could quite happily automate some systems for greater comfort and better sleep, as well as an injection of cool, fresh air to wake you up in the mornings, if this was connected to a ventilation system.
There's a building standard called Passive House. That's what I used to build to, and it requires certain things to be met, one of which is heating load of the property, but one important one is the ventilation. And you can see how data like this could be used to drive a ventilation system that provides temperature controlled, fresh air to living spaces to help normalise some of those peaks and troughs that we saw in that data. And actually, passive houses are really comfortable and really lovely to live in.
We aren't in a position to start renovating the house towards those standards, so for now we will just have to enjoy the hypothetical.
And to one extent, that's the end of this project in its current format. We're not going to do any more in terms of monitoring air quality, but we do have a few other automation projects in mind. There she goes.
Yep. It works.
This is you. I'm going to unplug that.
The next one we want to work on is pulling data down from the Met Office on sunrise and sunset and make some roller blinds that are actuated based on that data.
Or on a manual override, because I don't really want to have the blinds thrown open at 4 AM on a sunny Sunday in the middle of summer.
Keep an eye on the channel for the start of that project. It will be coming soon and will probably be just 2 videos with full build instructions.
I also really do want to work on an automated hydroponics system, and I'm submitting that as my final year project proposal for uni, but I don't think we're ready to do that here yet.
If there are any other aspects of home automation you want to see, let us know, and we'll see if we can work on that too.
I hope you've enjoyed the videos on this project, and I look forward to seeing you in the next one. So let us know if there's any questions, and see you around.
Bye for now.
Turn this thing back on. That is so scary.
Yeah, it's horrible.
I just want to touch it. Ugh. Just one last note to close out this video. Hopefully the audio quality, we've got to the bottom of that. We've done a few videos and a few different iterations of things, and so we had these other mics. The audio quality seems quite good on them. You'll probably be able to hear Ethan yawning. We were originally using one and passing it between us. That didn't work. It was too scratchy. So we've got this in a head. So we've got two. Stop spinning that screwdriver. We've got two of these lapel mics into a headphone splitter into one mic port that's then wired across the ceiling and down into the back of the computer. So you can't see what's going on here. But if it sounds good, that's what matters. Unfortunately, at the moment, we've got cable hanging here. We'll try and work out a different routing for this when we can. Maybe it'll come up on a tripod, and that's probably a better way of doing it. At the moment, this is kind of in the middle of the screen. But
why doesn't it just go along the floor?
Well, it's got to get up to our lapels eventually.
Well, yeah, but that can go along the floor.
Yeah, that would have been better. We'll work on that one for next time. Anyway, we're mid-exam prep. Our first exam is in like 2 weeks. What's the date today? 28th of April. Yeah. We've got 4 exams over the next 3 weeks. It's pretty hectic. So we might be a little bit sporadic on the old schedule, but we're working on it. We're looking forward to doing some stuff over summer. Yeah. Cool. Thanks for everybody that's watching. We really appreciate it. It's great fun to keep us accountable for these projects. We love doing them. So, yeah. Anything else?
Not really.
No. Happy days.
Yeah, happy days.
Ciao.
Bye for now.